Namaste everyone. Uh, Here in this class we are going to see Laplace transform of integrals. Now this Laplace transform of integral is a very important topic. Laplace transform of integrals. Here if I say that Laplace of if I say Laplace of f of t is phi of s, then Laplace of 0 to t f of u into du, this is equals to 1 upon s into phi of s. So this is Laplace transform of integral. When we have integral of the type 0 to t f of u du, then its Laplace is 1 upon s into phi of s, where this phi of s is Laplace of f of t. Okay, so let us first see its derivation. We have to find Laplace of 0 to t into f of u into du. So according to formula, it is 0 to infinity e raised to minus st into we have 0 to t f of u into du e raised to minus st into 0 to t f of u du into dt. Okay, this is what its value using the definition of Laplace. Now here we will apply u into v method. So here we will say that this is 0 to t, we consider this as u, so 0 to t f of u into du into we integrate it, so it is e power minus st upon minus s minus integration of, now here 0 to its limit is 0 to infinity, we integrate this e power minus st upon minus s, and we have derivative of this part d by dt of 0 to t into f of u into du. So integration and dt. Now here when I put here limit of integration is between 0 to infinity. So if I put infinity in place of t, I will get answer as 0, and if I put 0 in place of t, so here I will get integration limit between 0 to 0, and 0 to 0 value is 0. So this whole part is 0. Here it is minus minus plus, and we have 0 to infinity e power minus st upon s into, now derivative of this 0 to t f of u du. If I take derivative, then what I will get? I will get as integration and derivative they will cancel, and I will get f of t into dt. So this is nothing but 1 upon s into 0 to infinity e power minus st into f of t dt. So this is 1 upon s into this whole part is Laplace of f of t, or I will say that 1 upon s into phi of s. So this is Laplace transform of integrals. So again I will write the formula as Laplace of 0 to t into f of u du is equals to 1 upon s into Laplace of f of t. Okay, very important concept. Let us see few problems based on this. Now if here we have integration, 2 time integration, so I will say it is 1 upon s square. When 3 time integration, I will say that 1 upon s cube, and so on. So first very important question, we have to find Laplace transform of error function root t. So you have already seen the formula for error function, but now here we will derive it. So let us first discuss what is error function of x. So definition of error function of x is 2 upon root pi 0 to x into e power minus u square into du. This is definition of error function. Some of you must have learned this error function in your first year engineering. If you have not learned, then no worry. Here this is the definition of error function. Error function of x is 2 upon root pi 0 to x e power minus u square into du. So therefore, or I will say that hence, error function of root t. So by definition it will become 2 upon root pi. Here integration is between 0 to root t into e power minus u square into du. So I have to find Laplace of error function. That means I have to find Laplace of this particular part. Now here, if I put u square is equals to v. So if I put u square is equals to v, then u will become root of v and du will become 1 upon 2 root v into dv. Similarly, my limit will become, in place of 0 to root t, so I will say that as u is 0 means v is also 0, and as u is root t, v will become t because v is u square. So therefore I can say that therefore this error function ERF of root t, this error function will become 2 upon root pi. Limit will be 0 to t, in place of root t it is 0 to t e power minus v into 1 upon 2 root v into dv. So this is equal to, now this 2 will cancel, we have 1 upon root pi. Here we have 0 to t e power minus v into v power minus half into dv. Now let us first check what is Laplace of v power minus half. So Laplace of v power minus half, if this variable v is t, then we have it is gamma of half divided by s power half, that is root s. Now gamma half is root pi, so this is root pi upon root s. So this is Laplace of v power half. So therefore Laplace of, now if I have e power minus v into v power minus half, then this s will replace by s plus 1. So it will become root of s plus 1. So therefore now I will apply Laplace of integral. So 0 to t e power minus v into v power minus half into dv. This will become 1 upon s into root pi upon root of s plus 1. Now error function of root t is 1 upon root pi into 0 to t. So this is the definition for error function. So if I multiply by 1 upon root pi, so therefore Laplace of 1 upon root pi 0 to t e power minus v into v power minus half dv. So this will become, I am dividing this whole by root pi, so it will be 1 upon s into root of s plus 1. So therefore I will say that Laplace of error function of root t is equals to 1 upon s root of s plus 1. This is a very important question. Many times it is asked to find Laplace transform of error function. Now when it is asked to find Laplace transform, then if you directly write the formula, that is 1 upon s root s plus 1, you will get no marks. So you have to find out like this only. Now based on this error function, we can have problems like find Laplace of error function of root 2t. Now how I will get error function of root 2t? So this is we have multiplication theorem we have seen in the beginning. We will use that multiplication theorem and I will say that Laplace of error function of root t. So first, before that, we will first find Laplace of error function of root t, which is 1 upon s root of s plus 1. Therefore Laplace of error function of root 2t is 1 upon a, that is 1 upon 2 into 1 upon this s will replace by s by 2 into root of s by 2 plus 1. So this will become, this 2 and this 2 will cancel, and here it is 1 upon s root of s plus 2 whole divided by 2. So this 2 I will write in the top, root 2 divided by s root of s plus 2. Now there are problems like find Laplace transform of e power minus 3t error function of root t. So first I will find Laplace of error function of root t, which is 1 upon s root of s plus 1. Then I will use first shifting theorem. So e power minus 3t into error function of root t. This is equals to 1 upon this s will replace by s plus 3 into root of s will replace by s plus 3, so it will become s plus 4. Right? Okay. Now the next question I will discuss is find error function of find Laplace of 0 to t 0 to t 0 to t into t into sine t dt cube. So 3 times we are integrating. So by definition, if we are integrating 3 times, it will be equal to 1 upon s cube Laplace of t into sine t. 1 upon s cube Laplace of t into sine t. So I have to find Laplace of sine t. So Laplace of sine t is, we know that it is 1 upon s square plus 1, and Laplace of t into sine t. So multiplication by t, what we have to do? We have to differentiate minus 1 into dy ds of 1 upon s square plus 1, which is equals to minus 1. If I differentiate it, I will get tan inverse s. No. I have to differentiate is, so here minus 1 differentiate. So if I use u upon v, it is v derivative of u, which is 0, minus 1 into derivative of this s square plus 1 will give me 2s whole divided by s square plus 1 the whole square. So this minus minus will become, it is 2s upon s square plus 1 the whole square. This is Laplace transform of t into sin t. Therefore I have Laplace of 0 to t, 0 to t, 0 to t, u into sin u into du cube is equals to 1 upon s cube into 2s upon s square plus 1 the whole square. So this 1s will cancel and I have 2 upon here we have s square into s square plus 1 the whole square. This is my Laplace transform of integral, right? So thank you for this class. In the next class we will see few more questions based on Laplace transform of integral, and by that we will finish this Laplace transform. Thank you.